Hello students, in today's lecture video we shall discuss about metals. Metals are employed for various engineering purposes such as structural members, roofing materials, dam-proof courses, pipes, tanks, doors, windows, etc. Out of all the metals, iron is the most popular metal and it has been used in construction activity since prehistoric times. For the purpose of study, metals are grouped in following two categories. First one is ferrous metals, which contain iron as their main constituent, for example, cast iron, wrought iron, and steel. And second category is non-ferrous metal, which does not contain iron as their main constituent. And examples of non-ferrous metals are aluminium, copper. Important varieties of iron ores. The following are the important commercial varieties of iron ores which are commonly used in manufacturing process. First one is hematite, which is red oxide of iron having 65 to 70% of iron. Second one is limonite having 60% of iron. Third one is magnetite having 70 to 73% of iron. Pyrite having 45 to 47% of iron. Siderite having 40% of iron. Pig iron. The crude impure iron which is extracted from iron ores is known as pig iron and it forms the basic material for the manufacture of cast iron, wrought iron and steel. The pig iron is manufactured by the following operations. First one is dressing. Crushed into pieces 25 mm, impurities of clay, loam and other earthy matter removed by washing. Magnetic separators are used for magnetic impurities. Second step is calcination and roasting. Water and carbon dioxide are removing from ores by calcinations. By roasting, making the ores hot and very dry after removal of sulfur. Smelting. Smelting is carried out in special type furnace known as blast furnace. The raw material consists of iron ores, the fluxing materials like limestone and fuel like coal. Charcoal is allowed to go through throat portion of the furnace. By the reduction, the pig iron collects in the hearth of furnace. The slag formed is removed and hot gases dust escapes through outlet which is provided in the throat portion of furnace. Figure has been given to you. Here you can see the throat portion of the furnace. This is the cylinder. This is the hearth of furnace. This is the outlet for dust and gas. Cast iron. Cast iron is manufactured by remelting pig iron with coke and limestone. This remelting is done in a furnace known as cupola furnace, which is more or less same as blast furnace. Its shape is cylindrical with diameter about 1 meter and height about 5 meter. The raw materials are lit from the top and the furnace is fired. The impurities of pig iron are removed to some extent by oxidation. The molten cast iron is laid into molds of required shapes to form what we know as cast iron castings, and slag is removed from the top of cast iron at regular intervals. Here you can see the figure of cupola furnace, which is having a diameter of about 1 meter and height about 5 meter. Composition of cast iron. Cast iron contains about 2 to 4% of carbon. Manganese makes cast iron brittle and hard, so it may be kept below 0.75%. Phosphorus makes brittle and its percentage may be 1 to 1.5%. Silicon decreases shrinkage and ensures softer and better castings. And its amount should be less than 2.5%. Sulfur makes cast iron brittle and hard, and it should be kept below 0.1%. Properties of cast iron. If cast iron is placed in salt water, it becomes soft. It can be hardened by heating and sudden cooling. Cast iron cannot be magnetized. Cast iron doesn't rust easily. Cast iron is fusible. It is hard but brittle also. It is not ductile and cannot be adapted to absorb shocks and impacts. Melting temperature is about 1250 degrees Celsius. It shrinks on cooking. Its structure is granular and crystalline with whitish or grayish tint. Its specific gravity is 7.5. It lacks plasticity and hence it is unsuitable for forging work. It is weak in tension and strong in compression. Two pieces of cast iron cannot be connected by the process of riveting or welding. Uses of cast iron. For making cisterns, water pipes, gas pipes and sewers, manhole covers and sanitary fittings, cast iron is used. For making ornamental castings like brackets, gates, lampposts, etc. For making parts of machinery which are not subjected to shock loads. For manufacture of compression members. For preparing rail chairs, carriage wheels, etc. Cast irons are also used. Next one is wrought iron. Wrought iron is almost pure and it hardly contains carbon more than 0.15%, but the process of its manufacture is laborious and tedious. Wrought iron is manufactured by 4 operations: refining, putting, singeing and rolling. Properties of wrought iron. It can be easily forged and welded. It can be used to form temporary magnets. It is ductile, malleable and tough. It is moderately elastic. It is unaffected by saline water. It resists corrosion in a better way. Its melting point is about 1500 degrees Celsius. Its specific gravity is about 7.8. Its ultimate compressive strength is about 2000 kg per centimeter square. Its ultimate tensile strength is about 4000 kg per centimeter square. Uses of wrought iron. It is used for rivets, chains, ornamental ironwork, railway couplings, water and steam pipes, bolts and nuts, horseshoe bars, handrails, straps for timber roof trusses, boiler tubes, roofing sheets, etc. Steel. As far as carbon content is concerned, steel forms an intermediate stage between cast iron and wrought iron. Cast iron contains carbon from 2 to 4% and wrought iron contains 0.15%. In steel, the carbon content varies from 0.25 to 1.5%. The steel is manufactured by the following processes: basement process, cementation process, crucible steel process, duplex process, electric process, LD process, and open hearth process. Physical properties of steel. Carbon content. Variation in carbon percentage produces steel of different grades. Carbon always assists in increasing the hardness and strength of steel and decreases the ductility of steel. Presence of impurities. Silicon content is about 0.3 to 0.4%. Elasticity and strength of steel are considerably increased. Sulfur content between 0.02 to 0.1%. No appreciable effect on ductility or strength, however malleability and weldability decreases. Phosphorus content below 0.12% reduces shock resistance, ductility and strength of steel. Manganese content 0.3 to 1%, the steel becomes very brittle and hence it loses its structural value. Next property is heat treatment processes. It is possible to alter the properties of steel by heating and cooling under controlled conditions. The following are the purposes of heat treatment: to alter magnetic properties of steel, to change the structure of steel, to increase resistance to heat and corrosion, to increase surface hardness, to make steel easily workable, to vary strength and hardness. The principal processes involved in the heat treatment of steel are annealing to make steel soft, case hardening, the core of specimen remains tough and ductile, cementing, the skin of the steel is saturated with carbon, hardening, it is reverse process of annealing to make steel hard, normalizing, to restore steel to normal condition, and it is adopted when structure of steel is seriously disturbed for any reason. Tempering, this process is applied to steel which are treated with hardening process. Steel widely used in electrical machinery, etc. For making steel suitable for such use, its magnetic properties are given supreme importance, and these properties are obtained by carefully adjusting its chemical composition. Carbon content as low as possible and should not exceed 0.1%. Silicon, presence of silicon results in considerable increase of electrical losses, and hence it is highly undesirable. If the combined content of sulfur and phosphorus exceeds 0.3%, magnetic properties of steel are greatly affected. Manganese, if manganese content exceeds 0.3%, it proves to be injurious to magnetic properties of steel. Uses of steel: mild steel having 0.1% carbon, used as sheet metal, tin plates, etc. Medium carbon steel having carbon content 0.25%, it is used for boiler plant structural steel. Having carbon content above 0.45%, used as rails, tires, etc. Having carbon content above 0.6%, it is used as hammer, large stamping dies, etc. High carbon steel having carbon content about 0.75%, it is used as sledgehammers, springs, and stamping dies, etc. Having carbon content above 0.95%, it is used as minor drills, smith and tools, and mason tools. Having carbon content about 1%, it is used as chisel, hammer, saw, and other working tools. Having carbon content about 1.1%, it is used as axe, cutlery, drills, knives, picks, punches, etc. Nonmetals. Aluminium. Aluminium is important nonmetal, occurs in abundance on the surface of Earth in various forms such as oxides, sulfates, silicates, phosphates, etc. Bauxite is hydrated oxide of aluminium produced commercially. Aluminium is extracted from bauxite are as follows. Bauxite is purified. It is then dissolved in fused cryolite, which is double fluoride of aluminium and sodium. This solution is then taken into an electric furnace and aluminium is separated out by electrolysis. Properties. Aluminium is a good conductor of heat and electricity. It is a silvery white metal with bluish tint and it exhibits luster on a freshly broken surface. It is rarely attacked by nitric acid, organic acid or water. It is highly resistant to corrosion. It is light in weight, malleable and ductile. It is very sharp. It melts at about 658 degrees Celsius. It possesses great toughness and tensile strength. It readily dissolves in hydrochloric acid. Its specific gravity is about 2.7. Uses of aluminium. This metal is used for making parts of aeroplane, utensils, paints, electric wires, window frames, glazing bars, correlated sheets, structural members, etc. Copper. The important ore of copper are cuprite, copper glands, copper pyrites, malachite, and azurite. Properties. It becomes brittle just below its melting point. It can be worked in hot or cold condition, but it cannot be welded. It has a peculiar red color. It is a good conductor of heat and electricity. It is attacked by steam at white heat. It is not attacked by dry air but moist air gases. But when it is attacked by moist air, a green coating to copper surface appears. It is not attacked by water at any temperature. It is malleable, ductile and soft. Its specific gravity is 8.9. Uses. The market forms of copper are ingots, seeds, tubes and wires. It is extensively used for making electric cables, alloys, household utensils, electroplating, lighting conductors, dowels in stone masonry, etc. With this, we have covered the chapter of iron and steels. So if you have got any queries, you can ask me in the official WhatsApp group.